July 22, 1942. Bakhchi Sarai, Crimean Peninsula, Soviet Union. The railway spur had been laid in sections over 14 days, each railbed reinforced with double sleepers and crushed stone brought up from the quarries near Sevastopol, and now the assembled weapons sat beneath camouflage netting that did little to conceal its dimensions from Soviet reconnaissance aircraft that passed overhead in the early morning haze. Schwerer Gustav, the first of two 80-centimeter railway guns, designated by Krupp as Garret 040, had arrived in components aboard 60 freight cars in late May, accompanied by a construction battalion of 1,420 men under the command of General Karl Bette's artillery command staff, and the assembly had required 5 weeks of continuous work using 2 parallel tracks and multiple gantry cranes that lifted barrel sections weighing over 100 tons each into position. The gun measured 47 meters in length, with a bore diameter of 800 millimeters, capable of firing 7-ton high-explosive shells to a range of 47 kilometers or concrete-piercing projectiles of nearly 5 tons to targets 38 kilometers distant, and its total weight exceeded 1,350 tons, requiring 2 diesel locomotives to move it along specially constructed track capable of bearing the distributed load. Major Rudolf Rainer of the 672nd Heavy Artillery Battalion stood on the observation platform at 0534 hours, field glasses pressed to his eyes, watching the chalk cliffs of the Severnaya Bay where Soviet fortifications still held despite 6 weeks of siege operations by the German 11th Army under General Feldmarschall Erich von Manstein. And behind him, the gun crew of 500 men moved through their firing procedures with the mechanical precision of factory workers, each man trained for a specific task in the loading sequence that began with the hydraulic rammer pushing the silk charge bags into the breech. The morning air carried the smell of diesel exhaust and gun oil, mixed with the dry dust that rose from the limestone road surface where supply trucks had worn the surface into powder. And in the distance, the sound of conventional artillery, the standard 21-centimeter Morser 18 howitzers, created a steady percussion that had become the background noise of the siege. At 0612 hours, the fire mission order came through the field telephone network, transmitted from observation posts 3 kilometers forward, where spotters had identified a Soviet ammunition depot constructed within reinforced concrete casemates beneath Fort Maxim Gorky I, one of the primary defensive positions protecting the northern approaches to Sevastopol, and the crew chief, Oberleutnant Franz Kessler, repeated the coordinates twice before authorizing the loading of the first concrete-piercing round. The shell, designated Panzergranate, measured nearly 3 meters in length with a hardened steel tip designed to penetrate 9 meters of reinforced concrete before detonation, and it took 12 men using the internal hoist system to lift it from the ammunition car and guide it into the loading tray while the barrel elevation mechanism raised the gun to 35 degrees, the hydraulic cylinders hissing as pressure built within the recoil system. Rainer watched through the stereoscopic rangefinder as the target area came into focus, the concrete structure barely visible as a dark line against the hillside vegetation. And when Kessler gave the firing command at 0638 hours, the ignition sequence sent electrical current through the primer, detonating 1,960 kilograms of RPC-38 propellant in a fraction of a second that created a muzzle blast visible as a white-orange flash extending 15 meters from the barrel, followed immediately by a concussive wave that flattened the grass in a radius of 50 meters and sent shock waves through the ground that registered on seismographs in Yolta, 43 kilometers to the southeast. The projectile left the muzzle at 820 meters per second, its trajectory calculated to account for wind speed at altitude, barometric pressure, and the Earth's rotation. And for 93 seconds it traveled through the morning sky, visible to observers as a dark streak against the clouds, before striking the target coordinates with a deviation of less than 8 meters from the calculated impact point. The explosion, delayed by the penetration fuse mechanism, occurred beneath the concrete, creating a subsonic rumble, followed by a visible eruption of dust and debris that rose in a column 30 meters high. And within the fort's internal structure, the detonation caused catastrophic failure of the support pillars, collapsing 2 levels of ammunition storage and killing an estimated 73 Soviet personnel, according to reports compiled after the fortress finally fell on July 4th. The gun crew immediately began the reloading procedure, swabbing the barrel with water-soaked cloth to remove propellant residue, and checking the recoil mechanism for hydraulic leaks, while Rayner documented the firing sequence in the battalion log, noting barrel temperature at 340 degrees Celsius and recoil distance of 3 meters within acceptable parameters. Over the next 17 days, Schwerer Gustav fired 48 rounds against various targets within the Sevastopol fortress complex, including 5 direct hits on Fort Stalin, destroying underground magazines that had been considered impervious to conventional artillery, and an additional 7 rounds directed at railway infrastructure connecting the city to supply routes from the interior, each firing requiring between 40 and 60 minutes to prepare, depending on whether the gun needed to be repositioned along the curved track sections. The final bombardment occurred on August 2nd, when 8 high-explosive rounds were fired at the remaining Soviet positions near Cape Hærsones, after which the gun was disassembled for transport, the process requiring nearly as long as the original construction, and by mid-August, the components had been loaded onto flat cars for movement to the Leningrad front, where it was designated for operations against the fortified positions surrounding the besieged city, though mechanical difficulties and the deteriorating strategic situation prevented its deployment there. September 14, 1942, Rügenwalde, Pomerania, Germany. The second gun of the 80-centimeter series arrived at the Krupp proving grounds under circumstances of heightened secrecy, transported in sections from the Essen manufacturing complex, where final assembly checks had revealed tolerance issues in the elevating gear mechanism that required 3 weeks of metallurgical analysis and precision grinding to correct. And it bore the designation Dora, a name derived from the wife of the senior engineer Erich Müller, though official documentation referred to it only by its technical specification number. The weapon shared identical dimensions with Schwerer Gustav, the same 47-meter barrel length, the same 800-millimeter bore, the same operational requirement for 1,420-man construction crews and dual-track railbeds, but incorporated modifications to the breech-loading mechanism intended to reduce the firing cycle time from the 40-minute average recorded during the Sevastopol operations to approximately 32 minutes under optimal conditions. Oberst Heinrich Maeder, assigned as battalion commander for the 672nd Heavy Artillery Battalion's 2nd Battery, supervised the assembly work from a temporary command post established in a requisitioned manor house overlooking the Baltic coast, and his daily reports to Heereswaffenamt headquarters documented progress in mechanical terms. Barrel sections joined and aligned to within 0.2 millimeters of specified tolerance on September 22nd. Recoil mechanism tested to full pressure on September 29th. Electrical firing systems verified operational on October 3rd. The proving ground tests began on October 7th with the firing of inert projectiles into the Baltic Sea, each round tracked by optical instruments positioned at measured intervals along the coastline to verify trajectory calculations, and the weapon performed within acceptable parameters through 12 test firings before the first live explosive round was authorized on October 14th, sending a 7-ton shell 23 kilometers out over the gray water, where it detonated on impact with a geyser of white spray visible from the observation tower. By November, the weapon had been certified for operational deployment, and orders arrived designating it for transport to the Eastern Front, specifically to positions near Leningrad, where the prolonged siege had created a static front line similar to the Great War trenches, with elaborate Soviet defensive works constructed in depth and requiring the kind of destructive capability that only the 80-centimeter gun could deliver against hardened targets.
But rail transport difficulties caused by partisan activity along the main supply routes through occupied Poland meant that Dora remained in Rügenwalde through the winter months, its crew conducting maintenance procedures and participating in theoretical exercises while the strategic situation in the east deteriorated. The winter of 1942-43 brought temperatures that dropped to minus 23 degrees Celsius, and the hydraulic systems required special attention as standard fluid became viscous in the cold, necessitating the installation of heating elements around critical components and the development of new operational procedures for extreme weather conditions that had not been anticipated during the weapon's original design phase in 1937. Mader's staff compiled a technical manual running to 347 pages that documented every maintenance requirement, every firing procedure, every potential mechanical failure point, and this document circulated through artillery command channels as a reference text for similar railway gun systems, though none approached Dora's scale. In March 1943, new orders arrived canceling the Leningrad deployment and instead directing the weapon to positions near Warsaw as part of Army Group Center's strategic reserve, anticipating potential use against Soviet fortifications if offensive operations resumed. But the rail journey from Rügenwalde required extensive preparation, including the reinforcement of 17 bridge structures along the route and the construction of bypass track sections around curves with radius too tight for the gun's length. The movement began on March 28th, with the weapon disassembled into its major components: barrel sections, carriage assemblies, the massive base structure that distributed the firing loads across the track bed, each piece loaded onto specially designed flat cars with reinforced bogies capable of handling the concentrated weight, and the entire convoy stretched for nearly 2 kilometers when fully assembled, moving at an average speed of 15 kilometers per hour through the Polish countryside under heavy guard against partisan attack. The convoy reached the designated assembly area near Skierniewice on April 19th, a location selected for its rail infrastructure and proximity to hardened storage facilities where ammunition stocks had been pre-positioned, and reconstruction began immediately with the same methodical precision that had characterized the original assembly. Each component lifted and positioned according to the technical specifications, while survey teams verified level and alignment with theodolites and precision measuring equipment. The completed weapon sat on a curved section of track that allowed traverse through approximately 15 degrees without repositioning the entire assembly, and camouflage crews constructed false buildings around it, including a fabricated barn roof supported on wooden framework that could be quickly dismantled when firing operations required it. Through May and June, the crew conducted training exercises and maintenance cycles, but no fire missions were authorized, as the strategic reserve designation meant the weapon would only be employed in response to specific tactical situations requiring its unique capabilities. And such situations did not materialize, as the Wehrmacht's focus shifted to preparing defensive positions in anticipation of major Soviet offensives expected in the summer months. The daily routine became almost administrative in nature. Barrel inspection at 0600 hours, hydraulic system checks at 800 hours, crew training exercises at 1000 hours, ammunition inventory verification at 1400 hours, with Mader maintaining detailed logs that recorded every procedural step, every component's operational status, every man's training certification level, creating a documentary record that exemplified German military bureaucracy even in the management of its most extraordinary weapons system. When enemy aircraft appeared overhead on reconnaissance missions, the gun remained concealed beneath its false structures, its presence unknown to enemy intelligence assessments that focused on conventional artillery dispositions.
August 22, 1944, Auerswald, Lower Silesia, Germany. The withdrawal order arrived by courier at 0320 hours, carried by a motorcycle dispatch rider from Heeresgruppe Mitte headquarters.
and it directed the immediate evacuation of Dora from its position near Warsaw, where Soviet offensive operations had reached the Vistula River, threatening to encircle German forces that had not yet completed their retreat to prepared defensive lines further west. Oberst Mader, now serving in his third year with the Railway Gun Battalion, read the terse instructions by flashlight in the command bunker, while outside the crew had already begun the disassembly procedures, working under blackout conditions with only shielded work lights permitted, as Soviet artillery had begun ranging fire on rail junctions identified through aerial reconnaissance. The weapon had fired exactly 5 rounds since its deployment to Poland, 3 against reinforced concrete bunkers near Kovel in March, 2 against a fortified railway bridge near Lutsk in June, and each engagement had been documented in after-action reports that noted mechanical performance within specifications but questioned the strategic value of maintaining such a massive weapon system when conventional artillery or aerial bombardment could achieve similar results with far less logistical burden. The disassembly required 73 hours of continuous work, complicated by the need to conduct operations during darkness to avoid Soviet air attack, and the barrel sections proved particularly difficult to separate due to thermal expansion issues caused by summer temperatures that had reached 31 degrees Celsius, requiring the application of hydraulic jacks and controlled heating of the joint flanges before the connecting bolts could be extracted. By August 25th, the components had been loaded onto their transport flat cars, and the convoy began its movement westward, traveling only at night and spending daylight hours on sidings beneath tree cover or inside railway tunnels. And this pattern continued for 11 days as the retreat route crossed through territory where partisan groups had intensified their sabotage operations, destroying track sections and mining roadbeds in coordinated attacks that killed 17 guards and damaged 3 flat cars before the convoy reached the relative security of German-held territory near Breslau. The destination, Auerswald, had been selected for its extensive rail yards and repair facilities where Dora would undergo maintenance assessment before possible redeployment, though by September it had become clear that no such redeployment would occur as fuel shortages, material priorities for other weapon systems, and the general collapse of German strategic position made the gun's operational use increasingly theoretical. The weapon remained in its disassembled state in a storage yard where autumn rains turned the ground into mud and corrosion began attacking exposed metal surfaces despite the efforts of a reduced maintenance crew that had been cut from 500 men to fewer than 90 due to manpower requirements elsewhere. Mader received orders in October, transferring him to a conventional artillery regiment near Budapest, and his replacement, Major Kurt Alborn, arrived with instructions that emphasized preservation of the weapon for potential last-ditch defensive operations should Soviet forces penetrate into Silesia. But such instructions seemed increasingly disconnected from reality as the front lines contracted and supply networks disintegrated. Through the winter of 1944-45, the components sat beneath tarpaulins weighted with sandbags, visited occasionally by inspection teams from Waffenamt, who documented the weapon's condition in reports filed with headquarters that no longer had the administrative capacity to process such paperwork, and local civilians who worked in the rail yards began stripping non-essential metal parts for barter or personal use, a practice that guards were ordered to prevent but largely ignored as discipline eroded alongside broader military cohesion. In February 1945, a directive from Berlin authorized the destruction of Dora to prevent its capture by advancing Soviet forces, and on February 14th, a demolition team from Pioneer Battalion 23 arrived with explosive charges and cutting equipment. But the task proved more difficult than anticipated due to the massive scale of the weapon's components, and initial attempts to sever the barrel sections with thermite charges succeeded only in creating deep gouges rather than complete separation. The demolition work continued intermittently over 3 weeks, hampered by air raid alerts and the reassignment of personnel to frontline combat duties, and by early March, when Soviet reconnaissance elements reached positions within artillery range of Auerswald, the weapon remained partially intact, its barrel section scored and damaged but recognizable, its carriage assemblies buried under rubble from collapsed storage buildings. The final attempt to destroy Dora occurred on March 17th, when engineers placed explosive charges along the length of the barrel and detonated them in sequence, creating a series of concussions that shattered windows in the surrounding town and sent fragments of steel casing several hundred meters in all directions. But even this effort left substantial portions recoverable, and when Soviet forces occupied the rail yard on March 22nd, they found enough evidence to identify the weapon's specifications and photograph the remains for intelligence assessment. The photographs, later filed in Soviet archives, showed twisted metal framework, a section of barrel approximately 6 meters long split longitudinally along a weld seam, portions of the hydraulic recoil mechanism crushed beneath fallen concrete, and scattered ammunition components, including 2 intact concrete-piercing shells that had been abandoned when the storage magazine was evacuated. And these images would circulate among military historians as documentation of what had been the largest artillery piece ever constructed. A weapon that fired fewer than 50 rounds in combat operations, never achieved the strategic impact its designers envisioned, and ultimately served as testament to industrial capability divorced from tactical necessity. The crew members who had operated Dora dispersed into the chaos of the war's final months, some absorbed into retreating Wehrmacht units, others captured during the Soviet advance, a few managing to reach western zones where they surrendered to American or British forces, and in post-war interrogations, they provided technical details that filled intelligence reports examining German weapons development, their accounts describing not the dramatic effectiveness of a superweapon, but rather the mundane reality of operating a machine that required constant maintenance, consumed enormous resources, and delivered results that could have been achieved through conventional means at a fraction of the cost. And this testimony, combined with captured documentation from Krupp facilities, allowed Allied analysts to reconstruct the complete history of the 80-centimeter railway guns from their inception in 1937 through their final destruction in 1945, creating an archival record that preserved the technical specifications, operational deployment, tactical employment, and ultimate obsolescence of weapons that represented both the peak of German artillery engineering and the limitations of assuming that size and destructive power alone could determine military outcomes in industrialized warfare.